When learners move between different Linux distributions, one of the first surprises is that firewall management does not always look the same, even though the underlying goal is identical. You still want to control which traffic is allowed and which traffic is denied, but the tool and the style of expressing rules can feel very different. Uncomplicated firewall, UFW, is popular because it tries to make firewall policy easier to express in plain intent, like allow this kind of traffic, deny that kind of traffic, and keep the defaults sensible. That simplicity is helpful, but it can also lead beginners to make confident mistakes, because a short rule can hide a lot of assumptions about direction, interface, protocol, and default policy. In this episode, we build an exam-level mental model for the UFW approach, focusing on rule intent, common mistakes, and the typical reasons it blocks traffic when you think it should not. The goal is not to make you recite syntax, and it is to help you reason about why a rule behaves the way it does. If you can explain the intent of a rule and how defaults interact with it, you can troubleshoot UFW behavior without getting stuck in guesswork. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. A firewall policy is always a combination of explicit rules and default behavior, and UFW emphasizes defaults more strongly than many beginners realize. The system needs to know what to do with traffic that does not match any explicit rule, and that is where default policy matters. If the default for incoming traffic is to deny, then only traffic that matches an allow rule will get through. If the default for outgoing traffic is to allow, then most outbound connections will work unless you explicitly restrict them. Many UFW troubleshooting situations come down to the beginner forgetting what the defaults are, so they create a rule expecting it to be additive, but the default behavior is doing something else. The intent-first mindset begins by asking, what is the default stance for incoming and outgoing traffic, and how do my rules override that stance? If you keep that question in view, UFW becomes predictable rather than surprising. On the exam, when you see a scenario where a service is blocked after enabling the firewall, the default deny on inbound traffic is often the conceptual explanation. Rule intent in UFW is usually expressed in terms of allow or deny for a particular kind of traffic, and that is the mental model you should carry rather than specific command patterns. When you say allow a service, you are defining an exception that permits a matching connection. When you say deny, you are defining a block, which might be redundant if the default is already deny, but it can be useful for clarity or to override a broader allow. The key beginner idea is that every rule has scope, and scope includes direction, protocol, port, and source or destination. A rule that seems to say allow this might actually allow it only for one protocol, or only from one source, or only for inbound connections. If the real traffic does not match the rule scope, the firewall will still block it, and the rule will look useless to the beginner. This is where thinking in intent plus match conditions becomes essential. Intent is the allow or deny, and match conditions describe what traffic the intent applies to. Direction is one of the most common sources of misunderstanding, because people imagine traffic as a single event rather than a conversation with two directions. When a client connects to a server, there is an inbound connection request to the server, and then there is response traffic back to the client. Many firewall systems track state, meaning they recognize that response traffic is part of an established connection and should be allowed if the connection was allowed initially. Beginners can misinterpret this and think they need explicit rules for responses when stateful behavior may already handle it. On the other hand, if the inbound connection was not allowed, the conversation never starts, so no response rules will help. UFW is typically used with stateful firewall behavior, which is why default outbound allow can still result in inbound blocks when you enable the firewall. The intent-first explanation is that stateful tracking usually permits responses for allowed sessions, but it does not create a session in the first place. On the exam, this often shows up as a service that works from the server itself, but not from a remote client, because local tests bypass inbound firewall policy in ways remote tests do not. Protocol is another hidden assumption that creates common mistakes, because a port number alone is not enough to define traffic. Transmission Control Protocol, TCP, and User Datagram Protocol, UDP, behave differently, and opening a port for one does not necessarily open it for the other. Beginners often create a rule expecting it to allow a service, but they accidentally allowed the wrong protocol, or they assumed the service uses the protocol they expect. This can lead to confusing symptoms where some aspects of a service work and others do not, especially for services that use multiple protocols. Another protocol-related mistake is assuming that a service uses a standard port when it has been configured to use a non-standard port, which makes the rule miss the real traffic. In intent terms, the learner is trying to allow the service, but the match conditions do not align with the service's actual behavior. That mismatch is a core theme in firewall troubleshooting, and UFW simplicity can hide the mismatch until you think carefully about what you are actually allowing. Exam scenarios often describe services that were moved to different ports for policy reasons, and your reasoning should immediately include the possibility that a default allow rule for the standard service no longer applies. Source and destination scope are also easy to overlook because many beginner rules are written without specifying who the traffic is coming from. If you create a broad allow rule, you might unintentionally allow access from everywhere, which can be risky for services that should be internal only. If you create a narrow rule that allows only one source network, you might accidentally block legitimate users from another network segment. The same concept applies when you have multiple interfaces, because traffic can enter through different paths, and a rule might be intended for one path, but the traffic is arriving through another. UFW can express these scopes, but the key is to remember that your intent should match your trust model. If you want a service reachable only from an internal network, the rule should reflect that scope, not just the port number. On the exam, the right answer often involves recognizing that the firewall is behaving correctly according to a restrictive intent, and the problem is that the rule intent did not match the actual access requirement. This is why you should treat firewall rules as policy statements, not as random toggles. Another common UFW mistake involves rule ordering and how specific and general rules interact. Even when you express intent clearly, multiple rules can apply to the same traffic, and the system must decide which rule wins. Beginners sometimes add an allow rule, but a broader deny rule earlier in the evaluation path still blocks the traffic. They may then add more allow rules, which makes the policy messy without resolving the true conflict. The clean mindset is to think about whether a later specific allow can override an earlier broader deny, or whether the deny has stronger precedence in the configuration model. You do not need to memorize the exact implementation details for Linux Plus, but you do need to recognize that multiple rules can overlap, and that overlap can produce unexpected outcomes. If a rule that looks correct does not work, one possibility is that another rule is blocking first, or that the traffic is matching a different condition than you assumed. This is especially common when people copy patterns from guides without understanding the intent, because they accumulate rules that conflict. In exam language, rule conflict and precedence are common conceptual reasons a firewall blocks traffic. The question of why UFW blocks traffic also ties closely to the difference between enabling the firewall and allowing a service. When you enable UFW, you are activating its policy enforcement, which means defaults now matter and any gaps in your allow rules become visible as blocked traffic. Beginners sometimes enable the firewall as a security improvement and are surprised when remote access stops working because they did not explicitly allow the access method they are using. That is not the firewall being wrong, and it is the firewall finally enforcing a default deny posture that was previously not enforced. This is why administrators often plan firewall enablement carefully, ensuring that essential inbound access, like remote administration paths, is explicitly allowed before turning on enforcement. At exam level, this is a classic story. A system becomes unreachable after firewall activation because the required inbound rule is missing. The correct reasoning is that default inbound deny is blocking the service, and the fix conceptually is to add an allow rule for the needed traffic. Understanding that UFW is policy that must be complete before activation helps you avoid the beginner trap of assuming enablement is harmless. Another important category of failure is when an application is not actually reachable for reasons unrelated to the firewall, but the firewall gets blamed because it is the obvious suspect. A service must be listening on the expected port, it must be bound to an interface that is reachable from the client, and the network path must route correctly. If the service is bound only to a loopback interface, remote clients cannot reach it regardless of firewall rules. If DNS resolves the wrong address, clients may connect to the wrong machine and think the service is blocked. If the system is on the wrong network due to a DHCP issue, connectivity may fail before the firewall even matters. Beginners often open ports repeatedly in these cases, creating a more exposed system without solving the real problem. The disciplined mindset is to validate that the service is actually listening and that the system is reachable before assuming the firewall is the only blocker. On the exam, scenarios sometimes include clues that the firewall is not the root cause, such as local connections failing too, which suggests the service itself is down. Remembering that firewall rules cannot make a non-existent service work is an important sanity check. It is also worth connecting UFW to broader security intent, because the exam is not only about making traffic flow, and it is also about making traffic flow safely. A firewall configuration that allows everything is functionally convenient, but weak as a control, while a configuration that is too restrictive can break services and lead to risky workarounds. UFW's appeal is that it encourages a simple, least privileged style, where you start with deny inbound, and then allow only what you need. That approach maps nicely to security principles because it reduces attack surface and makes the allowed services explicit. The challenge is that you must know what you actually need, including administrative access, monitoring access, and application access, and you must scope those allowances to the right sources and interfaces. When you think of each rule as a clear statement of business and operational need, it becomes easier to avoid accidental exposure. This is why the episode focuses on rule intent, because intent is what ties firewall configuration to security design rather than to trial and error. On an exam, answers that reflect least privilege and clear intent often align with what is expected. To bring it all together, UFW becomes understandable when you stop treating it as a mysterious blocker and start treating it as a policy engine with clear defaults and match conditions. Rule intent is the allow or deny decision, but the rule only applies when traffic matches the defined scope, including direction, protocol, port, and source or destination. Common mistakes include forgetting default inbound deny after enabling the firewall, allowing the wrong protocol, assuming standard ports when the service uses non-standard ones, writing rules that are too broad or too narrow for the intended trust model, and creating overlapping rules where a deny overrides an allow. Another frequent issue is blaming the firewall when the service is not listening, is bound incorrectly, or the network path is wrong. The exam-level skill is to read a scenario and decide whether the firewall policy is incomplete, mismatched, or not the real cause at all. When you can explain why UFW blocks traffic in terms of defaults, scope, and intent, you will be able to design safer rules and troubleshoot faster without falling into guesswork.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.